All right, so let's begin. Yeah, my name is Yauheni, an Android team lead, and I'm working at EPAM. So today I'm going to present you my journey in crafting an AI agent, and I'll share with you my experience and some practical insights I got while I did it. So first things first, how come that I had to build an engine? Well, it all starts with a problem we probably all face. As a junior engineer, I read everything. That was kind of a way how I grew up as an engineer. And by everything, I mean practically everything. So I read books, I read articles, I read open source code, I learned some materials. So that was the way. But as a tech lead now, reading everything is now my responsibility. So yet I have less time than ever to do it. And if I miss a blog post about some new UI architecture or pattern, well, it's annoying. But if I miss a CVE security alert, well, it might be a disaster. The volume of noise, no problem. The volume of noise is too high for a human right now to actually maintain all the information we have. So I wanted to automate this diligence and at least try to attempt to do this. And if I succeed, it actually means that I can scale up my awareness to the levels that were not achievable for me before. The second reason was bridging the gap between theory and practice. So the thing is that I know quite well how LLMs work. I know quite well how agents work. But knowing without theory, it doesn't make any sense, right? So I wanted to get my hands dirty. I wanted to deal with actual problems, and I built it because building something with the tool is the only way to actually understand this tool and make it useful for you, or for me, in my case, right? But for this problem, right, is LLM agent is a correct tool? Is it a solution? So let's get it in parts. So LLM stands for Large Language Model. Basically, it's a neural network. If you remember 2017, 2016, neural networks was a buzzword like AI today during that period. But in the end of the day, large language models, they are still neural networks which are trained on a huge amount of text. And that makes them understand text, and generate them pretty well, right? So for our problem, it looks like a perfect match. We need to understand and some articles, some text, some release note, and provide an output, another text. So large language model is the choice. The second part is about agent. So agent, from a definition, it's an autonomous system that can make decisions and perform tasks with limited or no human intervention. That's ideal. That's what I want. I don't want to read it. I want the system to read it for me, and then I will just read the reports. So another benefit here is that agent can make an action. So we can probably ask him to notify me or someone else about some critical article it detects, or create a Jira ticket, or answer my questions if I will have some additional questions regarding the information it analyzed. So looks like the solution is correct. Right now, we need to shape the architecture of this software. And this brings us to the part where we need to ask some questions to shape the requirements and the architecture at the end. And let's start with the UX. So my goal was a tool that works equally well, both on my laptop and potentially could run on CI environment, so we can run it on schedules. It needed to deal with some messy inputs. We have some project context, we have API keys, we have diverse data sources, right? And we need to produce a clean, structured output, our report, with summaries, with criticality, with links, and with some actions. To handle this scalable complexity, and especially a data burden we have, well, I decided at the very beginning that everything that could be configurable should be configurable, right? So the X looks like this, like I described. The next one is performance and privacy. So I decided that the speed is kind of a non-negotiable. I don't want to run this tool, to run this agent probably for 30-40 minutes and wait for it to analyze everything. I want it to be pretty fast. So that was one of my requirements, because I want this tool to be performance and cost effective. As for the privacy, yeah, it was a harder constraint, just because, as all you know, nowadays, not all the companies, not all the people want to share their intellectual property, which code is, right? With some, well, let's say low authority MVP projects like mine. So I decided that for this MVP, we gonna use not a project code, but some publicly available project fingerprint. So what is that? It could be our dependencies. It could be our SDKs that we use. As I'm an Android, we can use some metadata like permissions. That application uses some capabilities and some description, right? As we are working with LLM, it can understand text. So we can describe our projects in words without sharing some sensitive data. And this makes this product kind of a trusty application, right? For running codes and terms, the strategy was simple. So we should be model agnostic. I don't want to train another model. I don't want to create another one. It doesn't make any sense. And I don't want to lock myself or any other user within some vendor-specific models, right? So we are model agnostic, and that means that we don't want to work with any frameworks provided by OpenAI, by Claude, and Anthropic, or anybody else. And we will rely on open source libraries and solutions like LangChain, PyTorch, and that's pretty much it. So we have pure Python, and the MVP, like I'm describing, it could be built probably in 30 hours or less. If you're an experienced developer, well, it will take, I believe, less. So what it means that our users will be running this software using open source libraries and models, so Llama 3 or any other open source model. But if you want to run it using proprietary model like ChatGPT, like Gemini, there will be the possibility for you to do this by providing some API keys and configuration. And yeah, this gives us the best from the both worlds. We are quite flexible here. And finally, shipping. So how we can deliver these to engineers, how we can use it. Well, I considered pretty extreme options. There were three. The first one was just to provide a raw code. So as engineers are the main target audience here for this product, not here, right? But here probably as well, I hope. We can just deliver the code. People will people will pull it and run the software. Well, doesn't work as I'd like it to work. The second option was to build something really meaningful, right? We can have some kind of a landing and people can use it practically like SaaS solution in the cloud, but that's an overkill for MVP, right? Someday probably I will be there, but not today. So our choice is a container. So we can create a container. It will have a repeatable self-contained environment. You can download an image, run it, and it will do the job. Before we proceed, we need to understand how agentic systems are actually architected. So there are two main types. You can have either a single agent system. It means that you have just one agent, you have input, you have configured your agent with some system prompts and instructions, you provide it with tools, guardrails, whatsoever, and this agent does the job, does the task according to what the instructions are. And in the end, you get an output. So in 90% of times, if you decide to write your own agent, this is your starting point, and this is a good choice. It doesn't require you to be, I don't know, an expert in this area. Practically everybody who has engineering experience can do this. Then we have multi-agent systems. So it becomes a little bit more complex. There are two main approaches we have here. So the first is called manager. As you can see, we have a main agent, a manager who actually receives the input. And then it is responsible for creating some kind of subtasks for other minor agents in the system. So they could do the job. And we get the output and proceed with this output to the user. So if you want an example, think of a translator agent where we have a manager who understands which language we need to work with. And then we have sub-agents like German to English, English to Polish, Polish to French. I don't know. Yeah. And this is a hierarchical approach. But we also have non-hierarchical approach. And here, all of the agents, they are working together as a one, right? If you want to have an example, think of IoT devices communication inside your house. So let's imagine that you have a thermostat agent that detects that the temperature in your room gets too hot, and it says it communicates to blinds agent that the blinds need to be closed. As the blinds are closed, they communicate to another agent, which is a lightning agent, to dim the light down. So as you can see, this is a really complex system, but it can solve a lot of complex problems, right? We don't need to write code. We write only agents, and they have clear instructions how to behave. However, you can imagine how difficult it is to debug or configure this system and actually track its performance and how it works. So if something goes wrong, well, good luck. So yeah, we have all of that. And before we go to the architecture of my solution, let's stop one more time on pros and cons of agentic systems. So definitely as a pros, agentic systems could deal with ambiguous inputs, with some unstructured data. They can understand natural language. No code can do this, right? So they could connect loosely coupled data and handle it pretty well, right? And yeah, we can extend the features and capabilities of these systems pretty fast. So if we need some new feature, we write some code, we describe this code as a tool for the LLM, and it starts using it. So it's quite fast from the idea of this feature to actual implementation, right? So with all of these pros, we still have cons. And the most important one here is that these systems are non-reliable. We can have 100 runs of our LLM's agent to do one task, and it will perform in really great 99 times, but on 100 times, on 100th attempt, it will fail. And yeah, it's just by nature of these systems. The reason is that we have a stochastic model that is working inside of them, and it is unpredictable. It's a black box for us. We know in theory how they're working, but we can't check, we can't open and look how it works. So yeah, this is the con number 3 as well. So if something fails, how can we debug and understand which part exactly fails? We can't fix it. It is not a line of code or stack trace, which we could have when we are working with, let's say, conservative software development. So it's another challenge. And of course, every LLM thought, right, it is costly. So we convert our texts to tokens. So each token costs us some money while LLM executes some operations with it. And of course, it creates some latency. One line of code execution on modern processors will take, I don't know, we can't even imagine which amount of time it is. It is a small fraction, not even of a second, probably of a picosecond, right? But when we talk about LLMs, well, it will be some problems. There will be some problems with latency. So back to our problem. It looks like, for me at least, that having LLM working with all of that stuff, right, with all of our pipeline, probably an overkill, right? If we think about it, if I was this LLM, what I need to do? I need to find an article. I need to understand whether I need to read this article and analyze it. then I need to re-verify whether I've already read something similar before, and then I read and analyze it, and then making the conclusions. So first 3 steps here are not something related to the pros of LLMs systems, right? And agentic systems. So given that fact, the architecture is looking something like that. So we have a central piece, some orchestrator, which have several modules that that form our pipeline. So as I said, we have everything config-based. The orchestrator takes this config, and based on it, it performs data collection, relevance check, then a database check, and only on the 4th step we have LLM to actually work for us. And then we generate a report. Pretty simple, pretty boring. So I decided that I don't have to deal with boring stuff while I implement it, because I still had to write all of this code. So I decided I would have a themed party. And our theme is ancient Rome. So all of these names comes from the Roman Empire war professions or military professions. So we have alligators, we have scout, vigil, archivum, speculator, and notarius. All of these guys, I will get you know with them better in a couple of slides. Let's start with a configuration. So for the config, we have 2 main files. .env file, so nothing special. Any secrets and tokens we are going to be used are there. And config YAML. So why YAML? Well, just because YAML is pretty simple, we can easily extend it, and there are a lot of libraries in different languages that can understand it and parse. So in a config YAML, as I said, we put everything. We put our project context, some paths to how we can find our dependencies. We configure our data sources and fetching rules. We configure models. Everything is there. So our agent, which is called Legatus, right, is responsible to understand and build this context in code. And who is Legatus? First of all, in Roman Empire, that was a commander of a legion. Sounds pretty strong. So every model in our application is a subordinate of this Legatus, and it reports to it, and Legatus gives commands to these models. So that's why this name was chosen. And I would say that there are 2 main things about Legatus in my software. First, it is a domain agnostic. So potentially, it is done in a way that potentially I can use this whole software piece, not only for Android, but with some extension of my config and config parsing logic with any other project you can imagine. So it might be cross-platform mobile application. It could be front-end application, it could be back-end application, anything. So the whole system is built in a way that we can potentially reuse it. And another one is a stateless runtime. So it was designed to be stateless because I wanted it to run not permanently, right? As I said, we have a container, we run this image, and while we are running, we do some stuff, and then we shut down. So we have some connections to the user using a config, right? Using some prompts configuration and all the stuff, but still it is not something which is permanently running on your laptop or in CI, and it doesn't consume any RAM. The next one is Scout. So Scouts in Roman army were the guys who gathered information. In our system, Scout's job is pretty much the same. So this part of the script is going into the internet and actually download for us RSS threads and all other data sources we would like to work with. So it started with a single threaded RSS. I then understood that, well, if we have hundreds or thousands of sources, it will probably slow us down. So it was rewritten to a concurrent system using Python's internal package, probably it's called async.io. And the second turning point was making the whole logic of Scout pluggable. So we can add new sources pretty easy right now. And I've decided to add a GitHub support. So we have GitHub release pages. And we can now read GitHub releases and have some summaries what has been changed there. So pretty good for an MVP, and it does work pretty well. Vigil. So this is our next model. In ancient Rome, the vigiles were the watchmen and guards responsible for protecting the city. So Vigil job in my software, in my program, is to act as a gatekeeper that filters out all the noise which we have in the raw data. So this is pretty important model, and it started with simple keyword matching, but obviously it failed, right? Then I tried enhancing it with some natural language processing tools like Spacey. It is a pretty popular library for Python to do this stuff, but it also failed, and it failed because the whole concept was brittle. So looking for specific words and match them with our project context, with our dependencies, well, it just doesn't work. We need to get the meaning of this, right? So Spacey and NLP enhanced didn't work. And for a moment, I was stuck. I knew that we have a main LLM in our system that can handle this pretty complicated task for me. But the thing is that it means if I use the main LLM here, that it means that all the articles we just search goes to this LLM and it will read everything. So we don't have any pre-filtering. It doesn't make sense. It doesn't save us money. It doesn't save us time. It just reads the stuff. So I came up with a general breakthrough. So we don't need a giant brain for this task. Actually, there are some specialized tiny neural networks, not LLMs, right? Neural networks designed specifically to capture the meaning. And the technique is called a semantic search. So what is it and how it works? So it's pretty fascinating and yet affordable technology. So the core idea is to convert text into a high-dimensional vector called embedding. So here you can see a two-dimensional vector is just for the purposes of example, right? But we have this embedding vector, and we can compare vectors that are correlate to our project context, right? So at the beginning of the pipeline, we use our sentence transformer model to build this vector in multi-dimensional vector, right? And then we use our articles with this model as well. And at the end, the only thing which is left is to have a cosine similarity comparison between our vectors. And this thing works pretty well. I was satisfied and I was happy when this worked for me because it was much better than a simple keyword matching. So this made a great leap for my piece of software, I believe. So the next one is archiving. Nothing special here. We need a database. The reasons we need it is just to make our agent not a stateless, but a stateful, but stateful in a term of memory, right? We need to memorize which articles we read before. The second reason, right, why we need it is to reduce costs, right? If we remember what we analyzed before, we can skip the step if we know that we don't need to do it. And yet another really good advice here is that if you can collect some data, collect it. Even if you don't use it, right? You can store it, and who knows how you can use it in the future. So this is a pretty popular approach. It's not probably practical, but you will see if it pays off in a couple of months, years, well, in some time. So yeah, it's just a simple SQLite database, by the way, and it is enabled by Python out of the box. So now we come to speculator. In Roman army, in Roman military, speculators were the specialized agents, and specifically intelligence agents. So in our system, speculators' job is to act as an expert analyst that processes the filtered information that comes to us from Scout and Visual. So there were two turning points here. So first of all, this model doesn't use the outputs from direct outputs, right? The text or summaries or titles from the Scout output. We have a link. We go with this link to original article and we scrape it. Why? Because we can't rely on the data sources all the time. And this is just more reliable solution. So I used a simple web scraping at the beginning and it failed. So there is a good library, kind of a industry standard for Python to do the scraping. It is called Treffilatura, and it improved the quality of the whole solution. And then I also decided that, as I told at the very beginning, that it's not enough just to analyze this article. We want to use LLM's capabilities as much as possible here. So it is analyzing and, based on your instructions, producing possible actions. So the action could be just a suggestion, what you need to do, or this action could be a real action that is then could be implemented in code and be, for example, triggering notification channel or creating a Jira prompt or calling your manager, everything you like, right? So yeah, that's pretty it of Pumpline, except we have a notarius, right? I believe everybody knows who is that guy. So in Roman administration, the notary were the official scribes and record keepers. In our system, notarius's job is to generate the final structure report, but it does it for free. Not as a notarius is outside of this building, right? So initially, we were producing just a CSV file report. Again, if you build something, that's a good start. This is a machine readable stuff. You can export it easily. You can look through it in Google Sheets, in Excel, everywhere you'd like. But I decided to extend it with a JSON file report as well, because who knows, maybe in some time, these agents would be deployed as a part of MCP server infrastructure, and we need to provide some reports using the network, right? So JSON fits it well. So yeah, the last step is about packaging and shipping. Well, Docker. Why? Because I don't want to use Kubernetes. It's not for that. Docker, again, is kind of a standard. You create an image and you can run it wherever you like. But there was a bad thing with that image. So 8 gigabytes, one image. Why is that much? I was shocked by the size. But the reason is that the open source libraries I was using, they are configured to run on any system. So they have a lot of stuff connected to GPUs, like drivers for NVIDIA, AMD, everything like that. So my agent is pretty small, and the task it is doing are pretty small as well. So I just cut off all the stuff that is not required for run, and it became 2.3 gigabytes. Not bad, not terrible. No, how it was in Chernobyl series. Not great, not terrible, right? Yeah, but still something you can work with. Another option here is to create even lighter version where we cut off almost everything and it will run directly on CPU, but it will wait only around 600 megabytes. Okay, very important question right now. Did I build an agent? Any thoughts? Okay, the silence is yes or no. It doesn't matter, because actually, formally, yes, it is an agent. But in fact, it is not. Why? Well, because agents are usually used to have to provide you answers to some open-ended questions, to deal with some ambiguity, right, with the data, which our usual program can't just work with easily, right? So again, I will repeat myself. Formally, yes, it is an agent, but in fact, it is not. And this is really similar to Pinocchio, right? Am I a real boy? So in our case, am I a real agent? Well, to actually address this, I decided that we can extend the capabilities of it. And I've just created a new feature. I've designed it, and this new feature could be formulated in a couple of questions. So what if I don't want to go into this CSV report, and I just would like to actually ask this system whether there was something really important in the last report, or please find me 3 most critical issues you found last month, or something like that. So to implement it, we can introduce another big module, which is called Inquisitor. So this is an agent. It has a tool, actually 2 tools for now. The first one is a SQL scraper, let's call it like that, and another one is a web tool. So you can see that they are working in a connection. Legatus run will update our database in archival module, and then Inquisitor can use its tools to work with this database and actually go to the network if it needs to re-verify something. So yeah, this is a really powerful pair of guys to implement our job. So meet the Inquisitor. Again, in the Roman Empire, Inquisitor was kind of a investigator that was tasked with searching for the truth. In our system, Inquisitor's job is to investigate our collected knowledge base, to answer specific questions, and I would say that there were 3 major things about it. So the first one is this React loop. So it stands for oh my God. It stands for, I forgot. Just a second. Okay. So basically we analyze the input and we act, right? So this is a loop which is kind of infinite, and we can end it with some exit token or exit instruction in our code. So this is a necessary thing if we want to have these LLM powers, right? Like answering open-ended questions. So the second one is the memory. So by default, any LLM agent is stateless, and it will forget everything you say to it instantly. So you just provide your input, it generates your output, and knows nothing about the previous input at all. So you need, as a developer, to manually provide this context every time. So this part of any agent would be needed to be done by you. The good thing is that it is pretty easy to implement, so you can scope it to 5, 10 previous answers and questions, or not 5 or 10, or infinite if you'd like. And third here is a control. So using small models goes hand by hand with infinite loops and hallucinations. So the fix here is not in a code. So we actually had a prompt to actually harden our prompt, right? So the prompt should become kind of a really strict instructions for your system. And this brings us to the biggest lesson of the entire project. So prompt engineering is not optional. It's kind of a mandatory tool, and it's the new coding if you're working with agents. So my early prompts were polite requests, probably we can say it like that. So they failed miserably. The agent hallucinated tools, ignored instructions, and spun into infinite loops. And to fix this, I had to start writing natural language code. So the final working prompt, as of now, looks more like some kind of a config, and it contains some critical sections in bold, rigid syntax rules and some specific instructions for the cases when the agent becomes confused. So yeah, by the way, this mem should also be synced. Yeah, looks better now. crucially, you should remember also that model size matters, and a giant model like GPT-4 or something similar can guess your intent from some vague prompt, right? But a less efficient local model like Llama 3 requires explicit, rigid guardrails to function reliably, right? You trade compute cost for prompt complexity. And as we are still in our theme, Roman theme, here's a stylized version of this meme as well. And one final piece of practical advice: adopt local first development strategy. So there are two reasons for this, right? First, obviously, it's free. So you can iterate hundreds of times without checking your API bill and without any harm to your budget. But second, and more importantly, local models act as ultimate stress tests. So small models are unforgiving. If your prompt is vague, they break. You can engineer a prompt that forces a small local model like Llama 3 to behave reliably, and then the same prompt will be bulletproof when you scale up to GPT-4 or something like that. So it's the best way to ensure your agent is robust. But please, don't run big models on your laptop. So it won't, it won't handle it, right? So choose your models wisely, or you burn your development machine. So, yeah. Okay. So what's the future of these legators? This two-agent system that was built, it creates a powerful foundation for true human-AI collaboration, and even agent-to-agent collaboration. There are more on GitHub about the development of the project. I don't know whether I will be willing to actively support it and develop it, but who knows? It would be nice, right, to have more powerful tools. Right now we have only two. We can extend it with more sources to support, and probably we can scale it up, as I said, to different domains. So this could be achieved pretty fast. Key takeaways from all of that stuff. So first of all, prompt engineering is a core development skill, right? The quality of your agent's brain directly proportional to the quality of your prompt. It requires iteration, testing, deep understanding of how to provide clear, unambiguous instructions. But the downside here is that your prompt should be, as I already said, right, should be adjusted, or you should have slightly different prompt for a different model. So you should keep it in mind. Second, this hybrid architecture is quite powerful. And again, choose the right tools for the right job, right? So don't assume you need fully autonomous agent that does everything. It won't just work. Or you will spend, I don't know, a year or two to writing it. So combining a reliable deterministic pipeline, if you have it, with focused LLM reasoning at the key points, well, it will give you the best of the best worlds, or of both worlds, right? Third, zero training AI is incredibly practical. Also, I'm thinking that we are moving as a community towards lower models, lower sized models, right? Which will be quite specific in some areas and domains. Right now, what we have with these large language models of a general purpose, like ChatGPT and others, well, that's pretty insane, right? And we can utilize it and work with it and build something really cool. And finally, yeah, the tooling is ready. As you can see on this GitHub page, it was done in a pure Python. It was done without any customization or creating some custom stuff from my side. I just used whatever was available for me. And yeah, you can do it as well. So I encourage you to try it, because I believe that we need this knowledge and this practice experience. And I hope that this talk will help you if you will try to write your own agent. Thank you for your attention.